So 2019, we'll do questions 2, 4, and 6. Question 2 here, complex numbers once again. And the key thing here, they give you a complex number to tell you a squared is equal to -1. So that shall never leave your head. The only other thing they might show you there is they might say I is the square root of -1. It's the same thing. So z2 is equal to 2z1. So I'm just going to work it out. Z2 is equal to 2 times my Z1, which they give up there, 2 plus A. Multiply that out, 2 2s are 4, plus 2A, and then we're going to fill it in. So 4 across, 2A up there, that's my Z2. Remember, this axis, once again, is my real. My Y sounds like A is my imaginary axis, and it tells us that your RE and your IM. Z1 cap is the complex conjugate. Now the conjugate, remember, just means change the sign of the imaginary bit. So Z1, I'm just going to write down here because I might need it, is 2 plus A. Write down the value and plot it in the diagram. So change the sign of the imaginary bit to minus A. So 2, and then down there, Z1 cap, Z1 conjugate. So they always either ask us modulus, division, or both. They're the key things in our complex numbers toolbox. So here, once I see them straight down lines, that means modulus. And I need the formula, the square root a squared plus b squared. If you don't know that, I'm bollocksed. So learn it. It's up every year, essentially. So we're going to have to work out is the modulus of Z2 the same as these other ones. So Z2 we seen up here was 4 plus 2A. So it's the modulus of 4 plus 2A. So that's the square root of A squared, which is 4 squared, plus B squared, 2 squared. No need for your A. We're just looking for a number, how far it is from the origin. Throw that into your calculator. Square root of 20, which is 2 root 5. Or you can leave it as the square root of 20 if you work it out in your head. Now the second bit is we're going to have to add these up together first and then find the modulus of the answer. So Z1 is 2 plus A plus its conjugate there, 2 minus A. Remember, you only necessarily need the brackets when it's a minus, but get into the good habits. So 2 and 2 gives you 4, and my I's go. Now, the modulus of that is just going to be 4, because it means how far it is from the origin, but I'll plug it into the formula regardless, just so you'll see that. So 4 squared plus 0 squared. The 0 coming from the fact that it's 4 plus 0y. And when you get through that into your calculator, you get 4. So there's my two answers. It says investigate. It doesn't say show or prove that. So are they equal? No. Next thing, show that this is a solution of this here. Now once you see that, you might be thinking that looks very familiar. You're right, you can use your minus b formula. And by all means, use your minus b. Only thing you got to be wary of is you cannot plug it all into your calculator, as it'll come up math error. Every time you do your minus b for complex numbers, it'll come up math error. So you have to work through it step by step yourself. Another way, and this applies in algebra, to show that something is a solution, what you can do is horse it in. That's my picture of a horse there. So everywhere there's a z, I'm going to throw in 2 plus a. So z squared is 2 plus a squared minus 4 times 2 plus a plus 5 is equal to 0. What does something squared means? It means 2 of those brackets multiply by itself. I multiply out this as well and tidy it up. So bust your brackets there. And anywhere you see a squared, you're going to sub in -1. I might do a wee bit of tidying up as well as I go, maybe with my i's. 2a and 2a is 4a. 4a minus 4a is nothing. Here I have 4 minus 8 is minus 4, plus 5 is 1, and then I've got my a squared. I know it says show that it is a solution, so I'll work out 0 is equal to 0. Therefore, is a solution. So if it is a solution, one side of the equation will always equal the other side. So even if I made a wee mistake here, write in that it is equal to 0, and someone marking it mightn't cop on. So I'm going to do 2, 4, and 6 functions I would like to show you with my calculator. 4 here, bit of algebra. Again, what we need to do here is to get rid of the fraction. Brackets, big dirty brackets around each. And then your lowest common multiple. So remember your multiples of 5, 10, 15, 20, and so on. Multiples of 2. You keep going on up till you get whichever one you get. And 2, 4, 6, 10, whatever one they have in common. And you get your 10. Now if you pick 30, you'll be okay as well. You'll get the same answer. So it doesn't make any difference if you don't pick the lowest. It just keeps things smaller. So your 10 outside each. And then cross off. How many times 5 going to 10? 2. 2 into 10, 5. 10 into 10, once. Then write down what you have. 2 bracket 3x plus 1 plus 5 bracket x minus 2 is equal to 1 bracket 47. Times them out. Maybe tidy up my left hand side. 6x plus 5x is 11x. Minus 8 is equal to 47. Numbers one side, letters the other. If it comes across, that equals the sign changes. And then to work with your x, divide by the number stuck onto it. X equals to 5. So I got a message here. On to the next bit. Simultaneous equation, one linear, one quadratic. So avoid the temptation to square that top line. Remember, there's a circle, there's a line, so it's my linear one. This is my quadratic or my circle. They're asking you where do they meet. So you work with the linear one, work with the simple one, try and get one of its letters on its own. So I'm going to get x on its own because there's no number in front of it. So x is equal to minus 13 plus 5y, or 5y minus 13 is the same thing. Now we're going to sub it in. Everywhere there's an x, I'm going to replace it with 5y minus 13. Plus y squared is equal to 13. What does something squared mean? 2 of those brackets. How are you going to multiply it out? You're going to bust your brackets. And just tidy that up. Um, 25y squared plus y squared, 26y squared, minus 130y, and to save myself a wee bit of time, 169 minus 13, 159, 156 equals 0. Now you could divide everything by 26 to make things easier for yourself. It's plus 156 there. Or do your minus b formula. I'll just do my minus b formula because that's the way I've taught it to you as a class. So work out my a, b, and c. A is 26, b is minus 130, c is 156. Write down your formula. And plug in the values. So I'm running tight for space. Remember your brackets around your B, crucial, especially when there's a minus, otherwise it spits out the wrong answer. One of the answers there is 3. This is y's actually, because it's a y squared. So y is equal to 3. You can go back and change that plus to a minus, and y is equal to 2. Remember, then you've got to work out your x, and this is where you go back up to the top. And we said there that x is equal to 5y minus 13. So we're going to fill it in there. 5y minus 13. 10 minus 13 is minus 3. If you can remember, write that as a point. Maybe your point is x, y. X minus 3, y is equal to 2. And repeat there in the other value. 15 minus 13, x equal to 2. So that point there is 2, 3. And then the last thing here we'll do is number 6, just more algebra. See brackets, anywhere there's a bracket, multiply it out, you'll not be far wrong. So we get 6 minus 2x less than 8. Now in these inequalities, I always say, keep your x positive, keep them happy. If we do that, we don't need to memorize about an out rule. Whatever comes across or divide by a minus changes the sign. Forget about that. Keep your x positive. How am I going to get them positive? I'm going to bring them to the right there in that's this case. That sign doesn't change now. And then to work out x, divide by the number stuck onto it. And then read from the x, read from this direction, x is bigger than minus 1. And once we see r, we're using a thick rule line. Bigger than minus 1. Don't colour in the dot because it's not included. And we're going all the way over there. And then the last thing here, solving equations using indices. Work downstairs before you look upstairs. So try and get 64 written as 2 to the power of something. So work downstairs, work with the big numbers before you go and solve that equation upstairs. You could just do trial and error of throwing in values in x here and see what spits out 64, you know, which isn't wrong either, like, but I'm going to do it the proper way. So to write 64, just put in 2 to the power 1, 2 to the power 2, 2 to the power 3, and you'll see there that 2 to the power 6 gives you 64. Now we've got downstairs sorted, we work upstairs. And upstairs we have 2x minus 1 and 6. That's the equation we're solving. And then just numbers one side, letters the other. 2x equal to 6 plus 1. 2x equal to 7. X equal to 7 over 2, or 3.5. I would suggest verifying your answer, subbing it back in up here, and you should get 64. And that's it. Questions 2, 4, and 6. Once again, complex numbers and algebra.